once you've succeeded at making a common denominator, what do? This one, two.
Together.
Say again?
Together.
Add them together. So what would the next line be?
Plus cos squared x over sine x cos x squared.
Oh. That's such a roll. Here, I'll give you an example. Same scenario, right?
Oh, it'd just be over sine x cos x.
There you go. Okay. But this is a good piece of advice as well. When you're doing a question like this that's got all this trigonometry and algebra in it, and you're second guessing something or you're not sure, go back to a basic skill and you'll be able to confirm, oh, that's right, it's just 4. Okay? Because it's all of those skills being used again. What do you see now?
Well, you can just.
Wouldn't it just be sine x cos x?
Oh, you mean like, can I cancel?
Yeah.
Okay, let's go back and try a scenario that looks like that.
Well, why would you?
So how about
That's
16,
the other side.
and the bottom would have a 4, and that could be a 25, and the bottom could be a 5. So it looks just like that. You're saying that I can go,
Yeah.
okay, so that would become 9, right? Check entering this correctly on your calculator. Put the top in a bracket, 16 plus 25, and that answer divided by 20.
Oh, no.
Just use the identity.
Patience. Is it true or false? It's false. When are you allowed to cancel? Well, you're allowed to cancel or reduce, but what's preventing this reducing that she's trying to do?
Plus sign?
Yes. Okay, remember I used to always say you were breaking my heart last year? Okay, this guy right here.
Oh, yeah.
Okay. Had that been a time sign, you could have done what you were thinking. So again, go back to a similar scenario. So, can't do that. Sawyer had an idea.
The identity sine squared theta plus cos squared theta equals 1.
Yeah, this is one of the identities I proved at the beginning of the class. That is one. Eli?
Aren't you already done the equation because you've got the same thing? Oh, no, you don't have the same thing. Well,
I
you
have the same denominators,
So
but I
that's
don't have the same numerators yet.
okay. So that's okay, gotcha.
Okay. So now I've proved that the left side does indeed equal the right side, so I've proved this to be true. So you'll notice that this uses a lot of previous skills. Okay, those previous skills, if you're not careful with them, you're going to make small mistakes. Try another one. Sine squared over 1 minus cos. Equals 1 plus cos. I think you're going to tell me the original piece, so I'll do that myself. I know it's a silly piece of advice, but write neatly. If you write really tiny or you write sloppily, you're going to make silly mistakes because you're not going to see what's really there. So will my first thing that I've already used twice work for this one?
No.
It's already sines and coses. But the thing I do notice,
Is there's one.
there's one oddball. If you ever play that game as Sesame Street, which one doesn't belong? No? Really? You guys ever watch Sesame Street?
No.
Yeah.
I think it was on there.
I don't remember it though.
You know, they'd show a whole bunch of circular things and they'd have something that was a rectangle and they'd say which one doesn't belong. Or it'd be colors and a whole bunch of reddish things and there'd be a blue thing. Which one doesn't belong?
Nope.
Which one doesn't belong?
I'd say the
Sign.
sign
That's the
squared.
oddball right there. So that's something I don't even have listed here. Okay? So when I look at the entire question and I see essentially the same ratio or the same trig values, and I see somebody that's odd, I'm going to focus on him. In fact, I want to replace that with something that's a cos.
The same as the bottom.
Say again?
The same as the bottom one.
No. Sine squared is not 1 over, or 1 minus cos.
But can you, these identities, can you move like, oh, because they're the square here.
No, go ahead and ask me what you were just
No,
going to do.
can you move the cos squared theta to the other side? But I forgot that that one isn't squared.
So wait a second. This is the identity as I proved it. She's saying, can I move terms around? If I move the cos to the other side,
But I didn't.
wouldn't this be true as well?
Yes, but that doesn't help.
Yeah, but it's not squared.
Are you sure? But wouldn't it get rid of the oddball and turn it into the same type of trig value, the cos?
Yeah, okay.
Yeah.
That's an advantage. So this is something new. Those
Can you
Pythagorean,
explain that though?
this here,
Yeah.
this is the identity that's on the sheet, right?
Where? Yeah.
Okay.
Pythagorean identity on the right side,
Okay.
okay? So by subtracting cos from both sides, I can turn that identity into a new version of itself.
Oh, okay.
Okay, you can do that with all 3 of those identities that are there,
Okay.
okay? So don't get stuck that it's only sine squared plus cos squared. It's any version of that. Okay, so if you prefer, you can add those additional versions by manipulating themselves on the paper. So if I take that version, I'm going to replace it right here. Now, it seems like we're not gaining much, but we have. We've got everything as cos. That's an advantage. Consider my list of options. I actually have the next step suggested in my list.
Well, you said use a form of 1.
Okay?
And I see ones.
Okay, so the form of 1 isn't because I see ones. Okay, the form of 1 for this one, this is what I would recommend, if that's the approach you want to take. Either that, notice where I got it from, or the alternate sign of it. That's the form of 1 that one would consider. It will work, but I see an easier way. Again, it's in my list. We've already done this. We can't do this because there's no second fraction. I just explained this will work, but I think it's a little early for us to bring that in.
I think it's 4 then?
Oh, okay.
Since
Be more specific.
since you pretty much said it's not 1, it's not 2 or 3 or 5.
I'm glad you were paying attention, that's good. Can you give me more specifics?
Difference of squares.
Exactly. This is 1 squared minus cos squared. This is a difference of squares.
How's that 1 squared?
Isn't 1
Because 1
times
times 1 is 1.
Where'd you get the 1 times 1?
Can I rewrite the number 1 as 1 squared and still have the same value?
Oh.
If it was 9, I could think of that as 3 and 3.
Okay.
Okay? So it's a difference of squares. Who remembers how to factor a difference of squares? I'll give you an algebra version. This is a difference of squares as well. How does one factor that?
It'd be like,
You just take the opposites. Wait,
it'd
what?
be x plus y,
Yeah.
and then x minus y.
Yeah,
Okay.
that's what I meant. With opposites, I meant opposite signs, like
Okay,
plus and
okay.
minus.
So that means that I go 1 plus cos. That's the first bracket.
Oh, I get it.
And the other one's 1 minus cos.
Okay.
Do you remember when I had you guys in grade 11? I didn't have you guys in grade 10, and I told you your factoring skills were going to become important.
Okay,
So they weren't important last year. They're going to become important.
are you allowed to cross out now?
You tell me.
Yes.
Because they're
Yes,
multiplying.
because I'm not canceling the 1. I'm not canceling the cos.
You're
I'm canceling
whole
the
bracket.
whole thing.
Okay.
Oh crap.
Okay, because the minus sign is holding those two pieces together. They have to travel together. This is the time sign right here. So it's all of that or all of that. You can't take part of it.
Okay.
Have I managed to get what I wanted?
Yeah.
Yes.
So I can write my 2 conclusions. And you'll notice every single time I write them. So don't ever say you didn't do this. Because I didn't.
I didn't see you do it this
I
time.
did it.
Therefore.